Why strength is less? For the class around 80 were there, now only 75. Okay. Also, this is the last experiment of your analog electronics. So this experiment using UA741 op-amp, design a window comparator for any given UTP and LTP and simulate the same. So we already studied in the theory what is comparator, correct, right? Comparator name itself suggesting we are going to compare the two voltages. So here what are the two voltages given, UTP and LTP. What do you mean by UTP? Upper threshold point. LTP means lower threshold point. So we are going to compare these two voltages and we are going to rig up the circuit. So they are asking us to simulate the same circuit in the software also. So what is our aim? To design and implement a window comparator for given UTP and LTP values. So what are the components required? These are the components required for hardware circuit. So op-amp 741, then diodes, then resistor, then regular power supply, then we require trainer kit also to give the power supply. Don't worry about this. These are the components required for hardware to rig up the circuit. What do you mean by this window comparator? So we already studied inverting or non-inverting comparator in the theory. So we are going to combine these two to make a single comparator. So here we are going to detect the input voltage level that are within a specific band or window of the voltage. So what do you mean by a specific window or specific band or window? So they are given the UTP and LTP. So within that, so the difference between UTP and LTP is there, right? So that we are going to consider as a window here. Okay. So here instead of having just one reference voltage value, window comparator will have the two reference voltages. So one is LTP and one more is UTP implemented by a pair of voltage comparators. So one which triggers an op-amp comparator on detection of some upper voltage threshold. So that is the V reference. So whatever the reference point we are going to take, that we are calling it as a V reference of the upper point, and one which trigger an op-amp comparator on detecting the lower voltage threshold level. So here we are going to detect two threshold values. So one is the upper V reference point, so that we are going to take the UTP, another reference voltage for the LTP. So the voltage levels between these two upper and lower reference voltage is called as the window. So whatever the voltage value will fall between these two voltages, that we are going to consider as a window. The voltage will fall within that window will take you to the negative side of the output waveform. We'll see it later. Okay. So here they are given the UTP as a 3.2 voltage and LTP as a 1 volt. So input voltage is a 10 volt. So the 10 volt is from peak to peak. Peak to peak means one cycle. So okay, then register to 1 kilo ohm. So however, these are the keys we will be working for uh, hardware. So this is the circuit to rig up in the hardware experiment. So like this you'll be getting, don't worry about this. So now we are going to do the software part, correct, right? So software part, so this is the circuit to rig up the window comparator. So what are the things are required? Two op-amps are required, then we require two diodes, then one resistor, then power supply, then trainer kits not required. However, through the power supply we are going to provide the 12 volts. Okay, here we are taken UTP and LTP as a plus 3 voltage and minus 3 voltage. So don't worry about the design and all. However, when it will come to the theory class means hardware part, I will explain in detail. Copy down this circuit in observation book. Copy down this circuit.
Ma'am, can you just zoom it, ma'am?
Okay, I'll zoom. Compared to the previous two circuits, it's little big one. So write carefully. Okay. Compared to first and second, this circuit looks big. So, but it's very easy. So draw it carefully along with the pin number, values and all. ಯಾಕೆ ಹಿಂಗೆ ಬರ್ತಿದ್ರಲ್ಲ ಏನಾರು ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಫಾಸ್ಟ್ಗೆ ಹೇಳ್ಕೊಂಡು
ಯಾವ ಹುಡುಗರಿಗೆ
ಇಲ್ಲ ಅದು ಗೊತ್ತಿರೋ ಮತ್ತು ನೀಟಾಗಿ ಹೇಳ್ತೀನಿ ಡೀಟೇಲ್ ಆಗಿ ಇಲ್ಲಿ ಎಷ್ಟು ಡೀಟೇಲ್ ಆಗಿ ಹೇಳಿದೆ ಏನ್ ಸಾಕಷ್ಟೇ ಥಿಯರಿ ಪುನಃ ಹಾರ್ಡ್ವೇರ್ ಲ್ಯಾಬಲ್ಲಿ ಇದೆ ಹಾರ್ಡ್ವೇರ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬೇಕು ನನ್ಗೇನು ಗೊತ್ತು ಹಿಂಗೆ ರಜೆ ಕೊಡ್ತಾರೆ ಅಂತ ಮನಸ್ಸು ಹಿಂಗೆ ಇರ್ತಾಳಲ್ಲ ಅಲ್ಲಿ ಹೇಳ್ ಕೇಳಿಸ್ಕೊಂಡು ಹೋಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ನಾಲ್ಕೈದು ಸಾವಿರ ಅಂದ್ಬಿಟ್ಟು ಎಷ್ಟು ಇದ್ದಿತ್ತಿಂದ ಹೇಳು ಎಷ್ಟಿಂದ ಹೇಳು
ಫಸ್ಟ್ ಐದು ಹಾಕಿದ ನಾಲ್ಕು ಹಾಕಿದ ಐದು ಹಾಕಿದ
6 4 24 ಇಡ್ಲಿ ನಾನು ತಿಂದಿರೋದೇ 7
ಈಗ
ಬೆಳಿಗ್ಗೆ ಮಧ್ಯಾಹ್ನ ಸೇರಿಸಿ ಸೊ 24ರಲ್ಲಿ 7 ಹೋದ್ರೆ ಎಷ್ಟು
17
17 17ರಲ್ಲಿ ಬೆಳಿಗ್ಗೆ 8 ತಿಂದಿದ್ಯಾ 9 ತಿಂದಿದ್ಯಾ ಬಿಸಿ ಬಿಸಿ ಹಾಲು ತುಪ್ಪ ಸಿಕ್ತು
ಜ್ಯೂಸ್ ಎಲ್ಲ ಮಾಡ್ಬಿಟ್ಟದೇನೆ ಕೊಡ್ತೀನಿ ಸಾಯಂಕಾಲ ಸ್ನಾನ ಮಾಡ್ಕೊಂಡು ನೀನು ಇದು ಮಾಡೋದಕ್ಕೆ ನಾನು ಪೂಜೆ ಮಾಡಿ ಹೊಗೆಲ್ಲ ಅದಕ್ಕೆ ಹಬ್ಬ ಏನೋ ಅನಿಸ್ತದೆ
ಈಗ
ಇಲ್ಲೇ ಇರೋದು ಇಲ್ಲೇ
ಈಗ
ಇರೋದು
ಎಷ್ಟು ಹಚ್ತೆ ನಾನು 1 2 3 4 5 6 ಹಚ್ಚಿದೀನಿ ಇದನ್ನೇ ಧೂಪಗಳನ್ನ
estimated amount
ಇವತ್ತು ಯಾಕೆ ತರಕಾರಿಗಳು ಬರ್ಲಿಲ್ಲ ಅಂದ್ರೆ
ಇಲ್ಲ ಅದೇ ಅವರೆಲ್ಲ ಸ್ಟ್ರೈಕ್ ತಾನೆ ಅವರು ಮಾರ್ಕೆಟ್ ಓಪನ್ ಇಲ್ಲಲ್ಲ.
ತರಕಾರಿ ಮಾಡೋದು ಏನು ತರಕಾರಿನೇ ಇಲ್ಲ.
GPD three zero 3303 plus 3303 plus 1 G. Second.
ಏನು ಮಳೆ ಬರ್ತಾ ಇರ್ಬೇಕು. ಇದು ಏನು ಈ ಥರ ವಾಸ್ತು
GPP.
ಈ ರೆಕಾರ್ಡ್ ಆಗ್ತಾ ಇದೆ ಸೆಷನ್. ರೆಕಾರ್ಡ್ ಒಂದು ಹಾಕಿದ್ದೀನಿ ಸುಮ್ಮನೆ.
ಮಾಡಿದೆ ತಾನೆ.
Guys copied. Only one fellow replied. Or you want some more time to copy it? Okay, Muhammad Saif is done. Asta, Anaga, Rakshit, Deepa, Deepali, Kavya, Mahesh, Mohan, Sudhir, Tushar, Suchita. Finished? Hope everyone are done. Can you rig up the circuits, guys? Just you already copied the circuit. Open the software. Try to rig up the circuit. Rig up the circuits. Open the software and rig up the circuit. If anyone facing problem to rig up the circuit, you can ask any doubts. A few people already finished and they are sending the output form. Still, anyone struggling to rig up the circuit? Guys, if anyone struggling to rig up the circuit, please drop a message. Arido 277. Check ಮಾಡಿ ಒಂದ್ಸಲ. 481. Where are the props? I told already when I was doing the first experiment only. If you get only black screen, then no props. Someone asking where is V sign? Go to V sign 347, number ending with 347. Go to source, take V sign. Yes, so many sent the output, it's correct. Who didn't get This one, V sign, go to place part, select source, type PSIN. So you can see the preview, you can take and you can place. 481, number ending with 481, it's wrong. Means you are getting only input waveform. Where is the output waveform? Missing value error. Check the component and check the wiring. No, it's not correct. Pranav, still it's not correct. The number ending with 879. It's wrong. You want me to rig up the circuit or will you do it? Please reply in the chat box. Okay. Can we do it once and show now? Okay. Those who are struggling to do the circuit, see it properly. I already done. I'll read once again. Okay. Those who are asking, ma'am, output correct. If you get this, it's correct. For maximum of you people, I didn't reply because it was correct. Only those output is not proper, for them only I reply. The people who got this screen, it's correct. Okay. Stop messaging now. Stop messaging now. Okay, I have displayed the output. If you get this waveform, it's correct. How it is, I'll explain later. Few people are asking me to rig up the circuit. Let me rig up. I'll open new project. So project name I'll give experiment 3. Then this is my default path where I'm going to save my circuit. So I'm going to create a blank project. Click on OK. I got the editor. So what are the things I require? I require 2 op-amps. So op-amp is present in so it's the name of the op-amp UVA741. So op-amp is present in the library eval UVA741. You can preview here. You can select 2 op-amps are required. Place it. Okay. Next, 2 diodes are required. 2 diodes are required. So what is the diode name? D14002. That is also present in eval library. 2 diodes are required. Take it and place it. Next, resistors. One resistor is required. Resistor is present in the analog library. Type R. How many resistors are required? One resistor is required. Place one resistor and rotate it. Next, what is required? Signal generator is required. Signal generator is available in the source library. Type P sign. P sign. So this is the signal generator. Take it. It is required on the left side of the circuit. Place on the left side of the circuit. Next, what is required? Power supply. How many power supply? How many power supply required? 1, 2, 3, 4, 5, 6. 6 power supply are required. 6 power supply are required. So that you need to type VDC. VDC. So that is also present in the source library. Select VDC. We require 6 power supply. Place 6 times. 1, 2, 3, 4, 5, 6. 6 power supply required. Wherever rotation is required, rotate it. Wherever rotation is required, rotate it. Here rotation is required. Yes. So from pin number 3 of op amp, it is connected to the positive. So still rotate it. Okay. Then from here it is going to connect it to the positive side. So rotate this. Again from pin number 4 of the first op amp connected to negative. So we need to rotate this also. Okay. Then here it is connected to positive. Rotate it. Again bottom is connected to negative. Rotate this. So here it is connected to positive. Rotate. Then what else required? Grounding is required. Grounding will take it later. I will take by myself. How many grounds are required? Here 1, 2, 3, 4, 5, 6, 7 grounds are required. So select source. In that select 0. Click on OK. So 1, 2, 3, 4, 5, 6, 7. 7 grounds are required. Now do the connection. So this ground I need to rotate. Rotate. So this is proper. This here also I required one more ground. Okay. Control R. So this ground is proper. This I need to rotate. Control R. This is proper. This one I need to rotate. Control R. So this is proper. Till here it's clear. Anyone is having doubt? Placing the components is clear, or anyone is having any doubts? So if people don't have laptop in your mobile, just go for recording. Okay. Now the next step is to wiring. Now I need to do the wiring. So pin number 6 of first op amp is connected to the diode. Again this 6 is connected to the diode. then from this end of the diode to this end of the diode, then from here connect to the resistor, another end of the resistor is connected to ground. So here there is a junction. Okay. Next, pin number 3 of first op-amp is connected to the positive of the power supply. Positive of the power supply. Negative of the power supply is connected to ground. Pin number 2 is connected to the one end of the signal generator. The another end of the signal generator is connected to ground. Another end of the signal generator is connected to ground. Here, pin number 3 is connected to, so pin number 2 is connected to positive end of the power supply, and a negative end of the power supply is connected to ground. Now pin number 3 of the op-amp is connected to the pin number 2 of this. Okay. So again, here also one junction is there. Here also one junction is there. Next, what else we need to add? Okay, pin number 4 is connected to negative. Again, positive is connected to ground. Here, pin number is connected to positive. Pin number 4 is connected to the negative. Another end of the power supply is connected to ground. So here also ground. So here pin number 7 is connected to positive end, negative end is connected to ground. I think connection is done. Correct? Connection is correct. Is the connection correct? Okay. Now we need to change the value. So what is the value we need to change? All the this voltage. See, this voltage should be changed to the negative 3, minus 3. So you need to indicate the sign also here. Minus 3 voltage. Click on OK. This voltage should set to positive 3. So just 3. Okay. Remaining 4 power supply. Remaining here 0, 0, 0, 0. These 4 power supply should be changed to 12 volts. Only these two are minus 3 and plus 3, remaining one are 12 volts. So change to 12 volts. Okay. Then what else we need to change? Signal generator we need to change. So 3 values are there. All the 3 values we need to set. What is V off? V offset is set to 0. Why 0? So if you set it to 0, the always means if the offset value is 0, the waveform will start from origin. Origin means it's 0. So what is the amplitude? Okay, this is frequency. Frequency is I think 1 kilohertz, sorry, 50 hertz. 50 hertz. The amplitude is 10 volt. So that is the peak to peak voltage. Then resistor value is 1 k. It's proper. Okay, all the values are set. Now Control S, save the circuit, create the simulation. Okay, now I got the simulating setting window. What is run to time? The run to time is 100 millisecond, 100 millisecond, 100 millisecond. Step size is 0.01 milliseconds. So I got this, I have not inserted the probes. So take the probe and put it in. So this is your input side. So this is your output side. Now control S. Once again run the circuit. Still anyone facing the problem to get the output? Hope maximum of you people got the output. Isn't it? Still anyone facing problem? If anyone facing the problem, you can reply yo, not in the WhatsApp, in the chat box. Pranav, still your output is not correct. Just now I rigged up the circuit and I showed the output also. I think it's Pranav only, 751. Isn't it? Is this Pranav, 751? Yes. So Pranav, what's the problem with your circuit? Send the circuit. Pranav, send your circuit. Others, any doubts? Why Pranav is not getting? Yeah, Pranav, it's correct. Pranav, it's correct, Pranav. Uh, 481. Can you send the output once? A 531. Number ending with 531. Check the output once. No, 481. Check the values. 481. Check the values. So what? How much voltage you are given here? Second op amp. Is it 1 volt or 3 volts? Three. Then you should get more. Wiring you check once. Wiring you check. Your curve is not smooth. Wiring you check once. Junctions are there. Two junctions are there. Check the junctions also. No. Something is wrong. Otherwise, you should get. Okay. See, twice I have done. Before the lab also I have done, and I reopened the new project and created. Without any error, I got it. Even so many are got. Okay, I think you have some mistakes in your circuit, okay? You later you check. Okay, guys, listen here, how we got this. So here we are going to compare the two voltages. It's okay if you are getting 0 to 0, 1, nothing to worry. It's not 2, it's 10 and 2. So peak to peak voltage we are giving 10, correct, right? So up here it will be 10, here will be 10. That's it. It's not 0, 2, 0, 1, doesn't matter. Okay. So how we got this output? So what are the thresholds where we are taken in the circuit? Threshold where we are taken minus 3 volt and plus 3 voltage. So look at this. So I already told what is the window. Window means minus 3 to plus 3 or plus 3 to minus 3. So plus 3 to minus 3, whatever the value is falling, that will take the output to 0. I think you can observe here origin we are set to 0, so it is now it is going to originate from 0. See here, so peak to peak voltage how much we are given? 10 we are given. So each subdivision, so there are 5 subdivision, each subdivision takes 2 volts. So first division is 2. We are taken 3, correct, right? So the second cell mid, it is crossing. So this is 3.3. 3.3. So from 3 point above, greater than 3 point above, this is your input. The sinusoidal wave is input, sinusoidal wave is input, square wave is output. See here, so this is 2, this is 3, correct, right? 3.3. Above the 3.3, above the 3.3, your output is changing state from negative to positive up to next 3.3. Remains in the zero. It is remains in the zero until it gets negative 3.3. Until it gets negative 3.3. See here it is 2, here it is negative 3. Negative 3. So not 3.3, it's 3. Exactly 3. So when it is negative 3, it is changing its state from 0 to positive. Until when? It will remains in the positive until next until next 3.3. So where it is, sorry, not 3.3, it's 3. Where it is 3, here it is 3. So after that, once it is again below 3, again it's changing state from positive to negative, and it is remains in the 0. So output voltage is only between positive 3 to 0. Input we are taking from positive 3 and negative 3, but output voltage is between only 0 and 3, positive 3. Okay, so positive 3 and 0. So when the output is above 3, it is changing state, and when it is below 3, it is changing state from negative to 0. Is it clear? Output is clear. Guys, output is clear. So that is the window. Window is nothing but excuse. See, this each cell here from here to here I have 10 nodes. Each subdivision carries 2 volts. Each subdivision carries 2 volts. So what is the voltage we are taken? 3. This is minus 3. Sorry, plus 3. This is minus 3. Correct, right? So this is plus 3. This is minus 3. So this is referred as a window. This is taken as a window. So whatever the output voltage will fall between this plus 3 to minus 3, it will remain in the 0. It is remain in the 0. When the input is above this minus, below this minus 3, it will change from 0 to positive. So it remains in the positive until it is above minus 3. Until it is above minus 3. Again above minus 3 to positive 3, its window. Within the window, the output will be remains in 0. Again above 3, it will change the state from negative to positive. Positive. Once it get window, that is plus 3 to minus 3, it will change state from positive to 0. Again it is below minus 3, again it will change the state from 0 to positive. Again when it gets window from negative 3 to positive 3, it will change the state from positive to 0. Is it clear now? No. Are you clear now? Aditya. Output voltage only 2, 3 and 0. Okay. When it is see, this is my positive 3, this is my negative 3, correct, right? So this is my window. This part I am going to take it as a window. When the input is in this value, the output value is 0. That's it, you need to remember. When the input voltage falls within this window, your output is 0. Apart from that, it's positive. Are you clear? Aditya Raj, still are you not clear? What about others? Any doubts in output? Any doubts in output? If you have any doubts, you can clarify now itself. See, if everything is correct, without any error, you will get the output. You people are seeing. I executed 3. I have executed 3 experiments. First 2 second. Even without getting any error, I got the output. I didn't do any magic. If the circuit is proper, without any error, you will get it. Even though if you get error, no problem. What are the problems will be there? If you get error, components are not connected properly or on the components wire will be passed. Only these are the two possibilities of error. Otherwise, components will be overlapped. I already in the first class itself I have told. So without knowing, if you continuously click the components up one after the another, it will be components will be overlapped. So even you won't identify. Just select and drag it. Then only you'll come to know. Any doubts in this? Nagendra? Nagendra, you there? Okay. Hope it's clear for everyone. If you have any doubt, feel free to ask. So if you didn't get output, try once again. Okay. Just take the component, connect it, change the values. But I'm sure you'll get it. Okay. Any doubts in these three experiments? Any doubts? It's easy, right? Guys. Okay. So still, if you want to practice, however, you have a software. Whenever you are free, when you will bore, you open the software, learn the circuit, and rig up the circuit. Okay. You'll see in the next class. Are we going to start with the hardware, or we are going to rig up the digital part? Okay. Answer attendance 1. Yes, in 1. Asta. Okay, absent. 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 21, 22, 23, 24, 24 is absent. 26, 27, 26, 27, 28, 29, 30, 31, 32, 33, 31, 32, 33, absent. 36, 37, 38, 36 absent. 38, 30, okay, 36 is there. 37, 38, 39, 40, 41, 40 is absent. 41 present. 42, 43, 44, 45, 43, 44, 45, 42 is not there. Okay, 46, 47, 48, 49, 46, 47 is not there. 48, 49, 50. Okay, 51, 52, 53, 51, 52, 52 not there. 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 63, 64, 65, 63, 64, 65, 66, 67, 66 is not there. Okay, okay. 71, 72, 73, 74, 75, 76, 77, 78, 80, 81, 82, 81, 81 is there, 82, 83, 84, 85, 86, 84 is not there. 88, 89, 90, 89, 90. Okay. Okay, guys. We'll wind up here. We'll meet it in the next class. 62. 60.